Question 6. Which amount of sodium hydroxide would react exactly with 7.5 grams of a diprotic acid, MR 150? Well, I've got a mass and I've got an MR, so I can work out number of moles. Moles is mass divided by MR. 7.5 divided by 150 is going to give me 0.05. That's the number of moles of the diprotic acid. What a diprotic acid means is that it's got 1 mole of the acid reacts with 2 moles of the sodium hydroxide. It's almost like you can think double strength acid. It's got 2 acids. Maybe it's like sulfuric acid where it releases 2 moles of H+, or it's got 2 carboxylic acid groups or something. But 1 mole of the acid reacts with 2 moles of the sodium hydroxide. So, which amount of sodium hydroxide, if I've worked out the number of moles of acid, I multiply by 2 to work out the number of moles of sodium hydroxide that I've got. 0.1 moles of sodium hydroxide is going to be needed. So concentration equals moles divided by volume. So moles is concentration times volume, and I've got concentration and volumes here. I need to get these volumes into decimeter cubes, so by dividing by 1,000, and then once I've divided each of these by 1,000 and multiplied by the concentrations, I'll work out the number of moles. The answer is C, because moles is concentration times volume. Concentration is 1 divided by 0.1 decimeter cubed is 0.1, and that matches the number of moles of sodium hydroxide that I need. Question 7. Lead nitrate and potassium iodide react according to this equation. In the experiment, 25 centimeter cubed of a 0.1 mole per decimeter cubed solution of each compound are mixed together. So I've been given a volume and a concentration. They clearly want me to work out moles. So moles is concentration times volume. Concentration is 0.1. Volume's got to be in decimeter cubed, so centimeter cubed up into a unit value, a higher unit value of decimeter cubed divided by 1,000, 0.025. I've got 0.0025 of each reactant. So which one is going to be limiting? Well, I need twice as much of this, 2 moles of potassium iodide, Ki, for every 1 mole of this. So this is going to be the limiting factor. This is what I need more of. This is what's going to limit it. Some of this will be left over because I don't need as much of this. I need twice as much of this, so this is the limiting factor. So I've got 0.0025 moles of both of these, but this is the limiting reactant. 0.0025 moles of potassium iodide is going to make half as much of the lead iodide. It's asking for the lead 2 iodide, which is PbI2. So 0.0025 moles of Ki, which is my limiting reactant, makes 0.00125. I've divided by 2 because 2 moles make 1. I've divided by 2, so it's going to make 0.00125 moles of lead iodide, which is 1.25 times 10 to the minus 3. The answer is A. Nitrogen monoxide is produced from ammonia and air as shown in these equations. 4 moles of ammonia, 5 moles of oxygen make 4 moles of NO and 6 H2O. And the enthalpy change for that is minus 909. It's exothermic with a minus value. It's giving out 909 kilojoules for every mole that I react. So this 4NO then goes on to react here. Now I've only got 2NO here. So the 4NO goes to react here, but I need 4NO reacting, not 2NO. 4NO is coming through from step 1. So I'm going to have to multiply all of this times multiplied by 2. 4NO, 2O2, 4NO2. Because I've got 4NO made in step 1, so I need 4NO reacting then in step 2. So I'm going to multiply this enthalpy change by 2 because I've got twice as much reactant, so the enthalpy change, instead of giving out minus 115 kilojoules per mole, it'll give out twice that. So my overall change is minus 909 plus 2 multiplied by 115, which is minus 1139. And the answer is D for this overall enthalpy change of a 2-step reaction.